Good morning, everybody that doesn't know me. I'm Patrick from Schleicher. And yeah, what shall I tell you about Schleicher? We are building the best gliders in the world, and that's it. No, it's a joke. We're talking a bit about our journey to electrification, because it was like a very long one and it has a lot of hurdles. So I will give you an insight about like our motivation, why did we start the whole thing, then what were our goals for this whole project, what is the technology we have behind all this, and what is coming in the future. So we're starting about the topic overview. We're going to have the creation part, then our lineup, what do we offer with electric systems, then the system itself, then how do you operate the things. A lot of you could already see yesterday how a 34 is working with the system. Then the performance of all the parts, how are you charging, or what are the maintenance things that you have to look at, and what is our future vision about electric gliding or the whole electric environment itself. So the beginning was, we created the ASG 32. So we had the first very heavy new performance two-seater, and we had no sustainer for this glider. So we had a self-launching engine with a rotary Wankel, but there was no sustainer in our company that was strong enough to lift up the 32, even with the 850 kilograms. So we were at the position to find a new sustainer for this big, new, wonderful glider. And the Michael Greiner, which already designed the 32 and the 29, thought about maybe we can use jet sustainers also at double seaters. So we tested the 29 with a jet sustainer, and we were like, nah, that's not the future. That's not good as a sustainer. It's fun to fly around with 150 kilometers with a jet engine, and it's very noisy and nice, but it's not going to be the future or the sustainer for our heavy gliders. So we thought about the electric sustainer, and there was none on the market. FES was just starting at that time. So we took a lot of universities of Germany, connected them, started the project, and applied for the funding of this electric sustainer project. So the conceptual phase of Martin Heide and Jürgen Greiner started at 2010. That was the first time where we thought about an electric sustainer. And then the project with all the universities, with the funding and everything together, started in 2013. So it's already 3 years of just making paperwork to start a funding project and not having done one single part of the engine. So then it was a lot of development because, like I said, FES was just coming at the time, and Lange was already in the game. So we went to the EASA and thought like, yeah, we can use the same regulations as Lange, right? And they were like, no, you're much later in the process, it's 2013 now, you need totally new EASA regulations. So we had to develop the whole system in an unknown environment with new regulations that we ourselves didn't even know we need. So the whole project took as long as to 2017 till we got the TC for the ASG 32, yeah, which is a very long time period with a lot of problems, but not because of the engine system. That was quite an easy work. Rainer Klein was also involved in the battery system and the whole project, but it took a lot of time to tell the EASA that the whole system was working and being safe. So we had a lot of work with this. Then, before we get more into details of the ME system, I wanted to speak about some important points and knowledge that some should have before, like, comparing different propulsion systems or electric systems in different planes. So, in the beginning, you have an evaluation part of tractor or retractable configuration, which means, are you using a RES? Or are you using a FES system? The points that you call tractor or retractable. So in our evaluation, we thought it would not be a good investment or good idea to use the relatively new FES system in a very heavy two-seater. we had like the problems that we see problems with the comfort because the nose is getting smaller because you have the engine in there. We just heard from the G, they have not that much of big problems with pilot size, but in the beginning, if you're starting the whole thing, that's something that comes to your mind that you don't want to decrease for the comfort of the pilot. Then also we have like safety thoughts about it. In the end, we heard a lot also from Thilo yesterday that you're flying around with 4 kilowatt or less, having level flight, but in our philosophy for the whole system, how a sustainer should work, it should take you away from the danger zone. You're pulling the engine at 300, 200 meter above ground, and the first thing everyone should do is get away out of this position. It's not thinking about how far can I come if I reduce the power. It's full power, getting away from the danger zone. That's what you want to have in the club. If you have like new younger pilots, you want a system that does not require them to calculate how much power can I use to come home. You want a system full power, away from all the danger and getting home. Then also in those evaluation for the configuration, you have the problem with the high mass. FAS works really well, like we see on 18-meter gliders, like a Ventus, like a LAC. It's a very nice system, but we also have to calculate with masses above 600 kilogram. Like the 32 can fly 850 kilogram, and the sustainer system should also should be really good working at high masses like 850 kilogram and still bring you home or out of the danger zone without any problems. And in the end, that's also part of the safety thing, is the full power climb. In our system, you don't think about your power levels, you just pull out the lever and then everything works with full power, brings you till the capacity is at 0, and then you're gliding home safely. Our philosophy in this whole thing was also to be in the best aerodynamic range with the gliders. So you're climbing at speeds 105, 110 kilometers, and at this speeds it's not very important if you're closing the engine doors. If you have them open, you have a big propeller that propels you out of the danger zone. You have low pilot drag or low system drag, and the propeller jet, if you're having like a retractable system like the ASG 32, is not hitting your fuselage at the front, it's not hitting your cockpit or anything, it's just in the free area and hitting your tail fin. So this is like our philosophy, and the most important point about all the things that we developed in this electrical sustainers is the don't use the limits. We don't want any component of our engines or our motors, our electric system, to be at the limit if you operate them. They should always be at the perfect operational limit, or not at the limit, at the operational power level, so you're not getting into heat problems or anything like that. It's always also good for the lifespan of all the components to be not at the limit at every time you use them. So then the last point is how to compare. We get a lot of comments from clients that say, yeah, but if you look at this glider, they have a climb rate of this and they have a range of this, and it's always people are comparing systems. That's totally normal, but in the end you never know where you got those informations from, because you only get the climb rate a lot of the time, and you never get what was around this climb test that they did. So our mass of climb rates that we say on our website, or if you ask us, are always ASG 32, 2 pilots, 800 kilogram. And that's the climb rate you can achieve with this. You can have 850, but we got to 800, which is 2 normal pilots, and then 32, and then climbing with the sustainer. And then also to compare motors or systems itself, it's always very, very important to know if you're calculating with shaft power or electrical power, because they differ by 10 to 20%. Electrical power is coming from the electrical power units, and the shaft power is coming from the motor. So that's really important for climbing. And in everything we publish, we always use shaft power, because that's the only power that you really use. You are not using anything before the motor, you're using what the motor is using, and that's what you get in your glider. So then we have our lineup. We have the 32 as the beginning, then we have the 34 as a prototype and testing device for our new motor system as a self-launcher. The goal for the 34 was to be as simple as possible. Everybody should be able to operate it. It should be very simple, very easy. It has no flaps. It's a glider that is used for many, many years, and a lot of people are very happy with this glider. It was our pilot project, and the ACE 33 ES was still in development while the 34 was produced. So then the next step we are going is the 33ME, which is our best 80-meter glider right now. The electrical motors opened up the way for minimum fuselage to be used as a self-launcher. You have no space for larger engines in the 33. We tried it, it didn't work. So you have a very aerodynamically clean design of your glider, but still have the possibility to have a self-launcher, so you don't have to make any compromise if you want to have the best glider on the market in the end. And also the self-launching 80-meter glider was a customer wish since many years, since the 29. The 29 also was wished as a self-launching 80-meter glider, so we started to develop in this direction.
But will it be self-launched at 600?
Yes. The 34 is 575, and the 33 will always be 600 self-launching. No problem. So now we get deeper into the 33 or the ME system itself. We have 2 times 35 kilograms of batteries in the 33. They are running on 400 volt. We are using also the 18650 format of the cells that Rainer also talked about yesterday and Didier told us about. Then our safety measures are 3 layers. So you have a cell layer that is covered. Then you have the battery layer, which is saved by our BMS, the battery management system, or we call it the Batman. So, and then you have the controller layer, which is also safety measures. Then you have fire protection, what we heard yesterday about thermal runaway and all the funny things that can happen on cells, or the other things that could happen. So we have fire protection in the cell layer, like we heard yesterday. Then the cell pack layer, so the cell packs that are connected are also fire protected. Then the batteries itself are fire protected, and then the wing case itself is also battery protected. So you have like a fire protection over 4 layers in the whole wing, and we have an extra safety layer in the pilot direction. So the cockpit is always extra fire protected from everything that can happen, because we heard of the gases in the case of a thermal runaway, so you're always protected in the position you're flying. It's tested for thermal runaway also in full-scale battery tests, so the battery was in the wing, fully tested for thermal runaway, and nothing eager happened. So we passed the test under the EASA, everyone was happy, and we also have controlled venting for the gases in a case of a thermal runaway on our wings. So everything is certified, everything is tested, so we are on the safe side with our batteries.
Just out of curiosity, does EASA have any representatives on site when you do the tests? Okay.
Yeah. So there are some EASA representatives that are looking over our shoulder while we crash cells or wings. It's always.
And as I understand it, they are expensive.
Yeah, they are.
Like in Sweden.
Yeah. Also for the flight test of the 34, they thought the Hohenrhein would be too dangerous to fly the 34, so we had to fly to another airport to show them how it works. But yeah.
Another question.
Yeah.
What chemistry is it on your battery? Is it lithium cobalt or
No,
lithium polymer?
yeah.
It's lithium polymer.
Yeah.
Okay.
So we are now in new studies for also other cells and batteries because in our thought, but I will talk about it later, or what we also heard yesterday is that the maximum mass you can bring in the air safely with a self-launch has like a break point. So if you go above 640 kilogram, the batteries are getting more heavier and you need more, and that's like the breaking point at the moment for us, where we think it doesn't make any sense to put an electric system into the glider if it gets that heavy for a self-launch. So we are also checking options for other cells, other batteries and other things. So.
Do you have cooling of the battery?
No, the batteries, we don't have cooling. We had 2 battery tests last week, and we flew in Germany at 36 degrees, which is pretty hot, and we used with the self-launch the whole capacity from 100% to 0, and they stayed very cool. We had no cooling issues or any problems, so that's also what the EASA checks if you're having those kind of gliders. Then we have the battery position, which is always a hot discussed topic for a lot of people. We said we position it in the wing because in the end a lot of customers also having a one-man rigging aid, which helps you with the wings. Then you have more useful fuselage load. For example, the 34 has 120 kilograms, which is amazing for a glider. And we have a low weight of the non-lifting parts. So we can achieve an easy system that don't need some tweaks in certain areas to lift off or to fly safe. Also, we get the smallest possible fuselage for the future. So we don't have to put all the batteries in the fuselage, and we thought about a better system for fire safety for us. We think it's safer to bring everything away from the pilot and also the batteries away from the fuselage. And in this system with no batteries in here, because you're a bit behind the point of gravity, you don't need additional trim masses in the cockpit or anywhere else to fly the system. Then our philosophy behind those batteries, we have a fire warning in every battery. It also works without BMS, so if you have no power left in your batteries, it still works as a fire warning. We have the multi-level security we also talked about, and we have an IMD, an installation monitoring device. So if we have cable scuffings in the high voltage system, the EASA requires to have an IMD. And we think it's already dangerous at 12 volt to use this thing, and we are using a bit more volt, so it's good to have an IMD in your cockpit or in your glider to be safe in every situation and always. You can't have enough safety, so we are putting all the safety into the system so the pilot is never getting harmed or anything. Then we have the whole system outside of the cockpit except for the lever where you control the power. So you have no high voltage or medium high voltage cables below your seat or anything to the motor in the front. We have everything in the back, which is also a thing that we thought about. And like Rainer yesterday said, the standard for high voltage says that above 50 volt AC voltage, it's already high voltage. So a lot of system or most of the systems for electric gliders use high voltage, which we want to keep away from the pilot. So normally you have a lot of voltage values from the manufacturers, but what's important is what is behind the power electronics. That's the voltage that comes out, that's the voltage that's dangerous. And if you have like above 50 volt AC voltage behind the power electronics, you're in a high voltage area.
Questions?
Yep.
How does the IMD work?
So if you have cable scuffings from the batteries or from the power electronics or anything, it sends a small signal. It gets a small signal and sends it to your controlling unit and shows you that that you have a cable scuffing anywhere, and cuts the whole connection for the batteries and the power electronics. So there is no power flooding through your glider. It cuts everything.
Do you have a mechanical isolator between? Can you?
Yeah.
Okay.
Yeah.
It's not CMOS conductors.
Yeah.
What is scuffing in Swedish?
Skruv, alltså skal.
Ja, de skal.
Skador på isolering.
Patrick, regarding the weight, what will be the weight with a normal pilot? Will it be 500 or 550 or something?
On which glider?
33.
So 33 in the end will be, depends on what you're putting into it, like retractable tail wheel. If you need, like some clients, 5 more batteries in there or anything, it will be around 405 to 415, depends on what you're using. And then you're having the 80 kilo of a pilot maybe in there. So but we have to calculate some way. So you're around the 500 if you're.
I think that means that you also have water tanks.
Yeah, it's going to be it's having water tanks.
So it will be no problem with the batteries and water tanks
No.
and leaking walls and.
No, it's no problem.
Okay.
It's we have to ensure that it's no problem. So the EASA is looking at our fingers very detailed, and we are doing this because the 33s should still be able to launch with 600 kilogram, and you should be able to get onto the 600 kilograms. So.
But the wing loading will be like 50?
Yeah,
empty?
and empty it will be 50, around 50, and then full you can fly with the 60. And we are testing at the moment also the possibilities of the 50-meter self-launch. It would be possible, but the wing loading with an empty glider would be close to nonsense. But a lot of people want it, so we are checking everything. But if you're starting with a 54 or 55 kilogram per square meter wing loading in 50 meter, it's more thought about, does it make sense or should it make sense? But yeah, that's the thing that we think about. So then the next is the power electronics. We're using an IGBT power electronics or motor controller, how you ever want to call it. It's in our voltages, it's highly durable and highly efficient. We have a passive cooling, that's why we keep the engine doors open. We have a larger layout for the power electronics, like for the motor or for anything else, for less thermal problems. And we have no dedicated cooler that needs maintenance or anything. It's just you keep the engine doors open. If you use the motor, it gets cooled, so you don't have any extra parts or components that have a maintenance problem or can get damaged or whatever. So it's a very simple and easy system that you have almost zero maintenance with. So that's what our philosophy is. Take bigger parts, bigger components, and you have less problems, higher durability, and less maintenance.
And it's the same component as the 32 EL, right?
Yeah, they are all on the same base.
Yeah.
So then we are going into the motor. Like I said, we have a large layout for best cooling, so the motor is running at 35 kilowatt shaft power. The motor could do 50. So we are having a much bigger motor. We are not taking the limits of the motor. So we have a much larger margin also for extreme temperatures. So if you're starting at 40 degrees, 36 degrees like we have, it should not be a problem. It's just a use case for all the temperatures. You can always use max power. The motor is running 2 minutes at maximum power, which is 35 kilowatt, and then you're using 25 to 27 kilowatt for constant power till the battery is empty. That's everything. It's not heating up. It's no problem. We have no extra cooling. We don't need new extra cooling for the whole system. So it's very simple, very easy, and very low maintenance. Then also what is important for a good completely system is the propeller. We develop all our propellers in-house, so we have the total control about the configuration for glider, mass, speed, and we have the quality in our hands, and we can tweak things if we have problems with the propeller or the motor. We have everything in our house, so we can tweak it to be the perfect result that we want to have. In the end, it's optimized, like I said, for the glider, for speed range, which is climbing speed. It's not like touring speed. And we have a lot of static thrust for the propeller, and the pilot angle is also optimized for static thrust. So you have a very pleasant self-launch. Also the pilot angle is optimized for best controllability. So it's not blowing under your tail or anything. It's perfectly adjusted to your tail. So you have a lot of controllability with your glider, which is very important in a self-launching area. Then we are coming back to the philosophy, what I told you. We want a sufficient design reserves in all the components, what we just said, so everything is bigger than it should be. We want to have the same performance in extreme situations like we have in normal situations. We have less maintenance parts. We don't have a mechanic to close the engine doors. We don't have an airflow system to cool the electro parts then with closed doors or anything. All those are parts that can get damaged or need maintenance. We don't want that. We want a super simple system for every club, for every user. It just should make fun. You don't need to be in the maintenance part of our company every day. And it has a lower complexity with this lower failure probability. Then you can also have the maximum takeoff weight, like we talked about, and we have a fully air-cooled system, so there are no extra parts for that. Then operating, very easy. You have the power switch, you turn it on, then you use the lever that we have for controllability, you put it into the extraction point. Then it tells you on the display to put the starter button to use. You use the starter button and then you just use the power lever to control your power of the engine, which is a super simple concept. If you're using it as a sustainer, you can put it directly into a power position and then press the starter button, it immediately works. And as our US representative said, as we had him, he said his clients need a glider with a switch that has 3 positions: fly, land, off. Everything more would be too complex. So with this system, we are close to having his dream or the client's dream achieved. And we also use the lever for improved emergency controllability, because we also saw that it's important to have control about your power levels on a very bumpy airfield or anything. And we have a large area where you can choose your power, which is a very good point, and we think it's the right way, and we love this design, so we choose it.
I found yesterday when we flew that the extraction time of the engine was about 14 seconds or so.
Yeah.
Is that the official value as well?
Yeah, we're here now 12 seconds
Okay.
for this, but it can be that the whole system in the prototype is a bit smaller, but on the serious production planes it's mostly around 12 seconds that we tested. Because Uli is testing every glider, and he also measures time, so
Okay.
it's around 12 seconds normally. So then we, like I said, 2 minutes of full power. It's 38 kilowatt of energy power and 35 of shaft power. We say 38 in here because in the system, in your display, you see the 38 of your electrical power. You don't see the shaft power. We are measuring their electrical power. Then you have the 25 kilowatt or 27 of continuous power, and you have the maximum range with sawtooth pattern is like something of the history, because with electrical engines you just use them till you can't climb anymore and then just glide home. But you could also use them in the sawtooth pattern. Then 12 seconds time to full power. We have a faster retraction than extraction, and the 33 will lift off with the 600 kilogram. We don't have any special takeoff procedure or anything. In the end, we are producing a serious product with EASA certification. We are not building experimental aircrafts. We are not building ultralight aircrafts. We are building EASA certified serious productions aircraft that are easy to use. So we have to. We also think a lot of the projects that we heard in the last days are very interesting. We are very curious about it, and it's very nice to hear how all the electric gliding goes forward and is evolving. But in the end, if we are thinking about the product or anything, we also have to think a bit economically. So it needs to sell, it needs to be certified, and it needs to be a serious production. So that's why we are at the point where we are at, and everything that we have in our gliders has to be certified. So that's the way we are going. Then what I told you already is the engine doors. We have low drag, so less complexity, less maintenance, and in the end, open doors are a very small portion of the total drag in those climbing speeds. Then charging and maintenance. If you're charging with 3 kilowatt, you are 4.5 hours till full capacity, which is pretty good. You can also use slower charging for increased battery life, or select the charging power for your hangar, because not all the hangars are able to feed 4 gliders with 3 kilowatt, because in the future you have to think about charging more than 1 glider in your hangar or at home or whatever. Then we have an automation that if you have like a power blackout, it starts automatically with your last chosen options. Which is very nice. So always, if you come to the airport, the glider is charged if you have power. And also it makes it easier to charge your glider into the trailer, because you can connect everything to the trailer, and then if you want to charge it, you connect the trailer to your power outlet, and everything works very easy and fast.
Patrick, regarding the charging,
Yeah.
you're thinking about, I'm having a Tesla, so I have my Tesla app, and I can adjust the charging and so on. Is that something that I like to have it in the glider.
Yeah, you have it in the glider. You have the selectable charging in the glider. In the display, where you control the engine, you can also control your charging power.
But do I have it on the Wi-Fi app?
That's what comes next. That comes now.
Okay.
So what I told you earlier about is like the increased battery capacity for increased maximum takeoff weights above 600 kilo for self-launchers. That's what we are working on. The problem also is like that we have like the CS22 certifications and everything running, so it's not that easy to just take a battery part and hope that everyone is satisfied and the EASA says like, okay, that's fine, everything's nice. So we really have a lot of paperwork and thinking about all this. Then also this needs to be durable. We are not building in the end a race car that is powered like for 30 minutes and then not again. We are having like a road car which you want to use every day, and it should work every day and not be destroyed. Also we have to think in all this about the gliding performance against the motor system, because our product, like the 33, was developed to be a very aerodynamically clean and good glider, and then the motor system came in, and we are not building a glider around a motor system. So the glider will always be the priority, and then the motor system will be fit into this glider. With the next point, connect the community, we are at the point where we think about the app. Lange has an app that is working pretty well, but we are thinking one step ahead, because we are an electric community. We are not Schleicher community or a Lange community or a Schleicher community. If the electric dream will get bigger and develop, we have to work together on systems. So if we are producing now an app with our charger for any system, it would be easy to have something like that. But in the end, we want to connect the community and share something with all the glider manufacturers. So if you're gliding with your 34, 33 or Discus FES to a different airport and want to charge it there, it should be possible to not have an own solution for every manufacturer. It should be a solution where you don't think about which glider you have. You just plug it into one of the charging stations that works with everything, and that's where you have to connect all the manufacturers together and the community to have like one standardized charging environment, and then you can start building around this charging environment.
Is it possible to get an onboard charger? Because I would like a glider like that, and then I would like to go on holidays, flying from gliding clubs to gliding clubs. We also think about this. It would be no problem to integrate it. It would be a bit more mass in the fuselage, but that's because the recent charger I've seen was fairly sizable.
It's 4 kilogram more in the fuselage. It's okay, but in the end, we are also thinking about this. And if everyone has its own charger with its own currents and voltage and everything, it's a mess. We are having the same we're having the same mess as in the car industry, that everyone builds its own charger system, and then you're charging here fast, here slow, and this is what we should. We have a small community, we have small manufacturers, so we should get around this point that the car industry showed us.
Are you cooperating with Pipistrel, for instance, or the power planes, because they have exactly the same problem? And I know there are standards.
That's the vision for our future, to connect to more than just gliding manufacturers, to have like one community of electric plane manufacturers, and then we could develop one dream for everyone together. That's what we are trying to do. So that what we think is the best idea, instead of having our own solution for everything, and then everyone has to go around it, and then you're landing on an airport, and it's all a mess. So it should be one system, and everything is getting together. And then in the last point, we're working on the options and solutions for extreme environments. For example, here in Sweden, if it gets very cold, below 0 degrees, you're losing capacity of the batteries because our batteries are not heated. Below minus 10 degrees, self-launching is not that good anymore because you lost already a lot of capacity. And below minus 20 degrees, you're not able to charge your batteries because they are too cold for charging. So we are already working on heating solutions for extreme environments like the north. So that's what's on our plan.
We fly a lot of waves here in Scandinavia, and sometimes minus 50. So you still recommend the K21 for wave flying?
Always.
I have another question here. Observation. The slide, the glider behind is the 35.
That's true.
Are you thinking of electrifying it?
Yeah, that's what we are telling you about the 600 kilogram, because we also wish that the 35 is going to be an electric glider, but it has like a maximum takeoff weight of 735 kilogram. So the energy density now in those batteries are not perfect for lifting off those big gliders. It could be a sustainer, but if you have such a glider, you want a self-launcher. So we are waiting for increased battery capacity for bringing 35 into the electrical air. But we are thinking already about it. That's why the picture is in the background. And,
What is the lifetime of the batteries?
Approximately 13 years right now.
Do they need to be replaced after 13 years, or what is this certificate?
They are losing capacity, or they are starting to lose capacity after 300 charging cycles or 13 years.
Okay.
So that's the point where you can still use them, you can still add them as a sustainer or self-launch, but they are starting to lose capacity. So that's the point in this lifetime. Yeah, now we are at the end. Thank you for your attention, and I have a lot of 34 brochures that you can take if you want to, with a lot of beautiful pictures in here. They look like this, so you can just have one with like 100 pieces of it here. So.
How much money? What's the price?
Russia?
No. if I pay 200,000 euros for the brochure, will I get a glider for free? That's but what is the price of the 34 roughly?
34 is around naked,
Yeah.
always naked.
Yeah.
Around a bit more than 140
Okay. Plus VAT. Yes.
without any.
Yeah. Okay.
Yeah.
I have a question that's probably very difficult to answer, but what do you, as a company, where do you see the future in pricing for, I mean, I have no idea what you pay for the motors, for the batteries, etc. From a price perspective, we know that the battery prices per kilowatt hours is certainly going down.
Yep.
What about motors, inverters, and things like that? Do you see like a flat screen moment, a flat TV screen moment?
We calculate with a decrease in price for all the components because they are used everywhere. They are like a big product now, so we are calculating with reducing price.
Do you have any industry like electric motor battery industry projections about pricing in the future, or no?
What are the delivery times for the 34 and 33, I mean?
The 34 is around 3 years. 33 ME is around 3.5 years.
So we have some time to save.
No, it's best to produce by
But there is another problem with these long delivery times, and that is that the glider population is getting older and older. I remember when we were there more than 10 years ago at Schleicher and flew the prototype of the 31, I asked Uli, what is the delivery time of the 31? He said 3 years, and I said, oh, that must be very good for a producer, with long. The company stay said, no, it's not good. He said, because the first 3 customers were 74, 75 and 76 years old. There is a risk that they will die before they get the glider. So that is something to think about in gliding. We must get younger.
Yeah, that's what we hear a lot. Like I'm doing a lot of sales things for Uli now, and a lot of the customers say, "Yeah, do I live when my glider gets produced?" And I'm like, yeah, hopefully.
Patrick, some words about the new open class from Schleicher.
Yeah. What do you want to hear?
Everything.
So the 35 is going to be the new open class from us. We decided to 20-meter wing layout. It sounds crazy around those EB29s jetting around in the air, but we looked at the last competitions of 7 years, so 7 years of world open class competitions, German open class qualifying competitions, and we saw the trend that those open class tasks on the competitions are getting smaller and smaller. They are always the last in the grid, so you have 2 classes that get towed before, and then they have like a small task, so they are using only the best time of the day. And if you look at the open class competition that just took place, they had like almost every day 130 kilometers per hour speeds. So if you're going to smaller tasks and don't need the low thermals at morning and the low thermals in the evening and the long glide path, it's always coming down to who has the most wing loading, because then you need to be faster around the task. And that's what our philosophy was for this glider. Seeing the last 7 years, seeing the trend in the open class, then reducing the wingspan and having then also a glider that everyone can handle at the ground. You have a relatively light glider, you only have 20 meters to handle on the ground, which is like very positive for all the people that don't want to handle 28 meters of wingspan anymore and high weights. So the glider is going to be hopefully a beast, and it already looks amazing. So we hope that this idea is going to be the key. A lot of people are curious about it and don't think that maybe it was the right idea to have such a small wingspan, but we think the combination of the pilot that flies every day and just want to fly 3 hours with the self-launcher and have a nice glider, and the people that want to go to Uvalde or wherever the World Championship is and have small, fast tasks should also be happy with it.
So it will be ready for Uvalde.
Hopefully.
Okay.
One comment about the tasks. That's going to change. So we're going to change the classes, and we'll make more difference between the types of tasks in the different classes. And the open class, of course, they're almost all self-launching now, will move up in the front, and they will be the first starters and the last to get home. And it will be, I'm not saying that to, because we want to make difference between, we don't want to have 3 different classes with the same type of task. So what we are going to see in the future is tasks for open class that are undoable. So it's going to be distance tasks for the open class. So the task will be so long that there's no chance you can fly.
Peter, we asked for that from the team.
But that's what we have.
In Szeged,
Yeah.
but then it was the case, the airfield is too short.
Yeah, you're right. So and this is not happening tomorrow. I'm just telling you a little bit what the thoughts are, and I will see. So having said that, the main problem in Szeged, but it was not a typical competition and typical weather. My main problem in the open class was the red line. That was this LXA overspeed in the glides, because and because you just flew the glides, you just flew to the red line. I mean, or as fast as you dare to fly with the long wings and the turbulence. So what I was looking for was that the green area is moving up, so I could fly faster in turbulent weather. That's but Szeged is not typical.
But you choose the long wings.
Yeah, but there's only in the 29 you only have one.
Okay.
That's only one. Now, Uvalde is going to be the same. We know that. And we may probably see that gliding competitions, the World Championships, are going more and more to places with good weather. So I do not disagree in your design choice. I think it's the right choice. Because what we also saw is there are 2 types in the open class, the DP29 and the DS1C. The DS1C, which is actually not really an open class glider, it's a modified 18 meter with some extra wingtips. But it was very rare occasions where we had an advantage in the 29. The DS1C was as good performing because we never flew best glide. If we would have had one day with a very long final glide from a very weak terminal, I would have beaten the DS1s. But the conditions we had, they were actually sometimes, I would have preferred flying in my 33. But I didn't know it was going to be that good, better than for me than it is.
Yeah, that's a point that we already saw now in the 33, that with the high wing loading and still climbing that good and that easy, we want to adapt that to the 35, make the 33 a bit bigger, and you're having a nice glider that can pretty good fit in there. So, and also the other idea was like to have a glider for the everyday pilot, the self-launching pilot that wants to have like an 80 meter or 20 meter easy, lightweight glider in this class. You're having the options of 2 classes, you're having a nice glider for every day, and you're still having the high wing load of 63 for those days you just described.
But the 35 will only be with the Wankel, not with electric.
Yeah, at the moment it's going to be with the Wankel, but as I said, we are thinking about electrifying it also. But for electrifying such a heavy glider as a maximum takeoff weight, you need higher energy density in your cells and batteries.
Okay, very interesting discussion, and I think it's a good thinking that we have to change this philosophy about rating, and then we have the E-glide for the future.
The E-glide is coming.
But the E-glide, to be fair for all electric gliders, has also to change a bit, because in the end, with the actual regulations right now, Ventus or LAC is the best, and everything else is.
But they are thinking of that, I can see now.
Because
there will be some changes next week.
There will be
gradual changes, but that's something.
But it's, I mean, if you just use the aerodynamics you learned for your license and calculate it, if you want a wing level of 63 kilo and the small wing area, and an aspect ratio of 35, 37, you end up with 21, 22 meter. That's just you don't have to use the math software. You can use it on your calculator. And I think that when I was young, one of my big stars was George Moffat. And he published his book, Wheeling on the Wind, I ordered one and I sent it to him, and he wrote it. And there he writes, there is no substitute for span. And I have all my life I have said that there is no substitute for span. But now I think maybe that the real word is there is no substitute for wing loading.
There's no substitute for stability of the wing, because that's the problem getting with the span, that you create so much drag at high speed and turbulence that it becomes a disadvantage. Yes.
Okay, thank you very much, Patrick. Although it's in Swedish, but there are many nice pictures.
Yeah, thank you.
A lot of from the history of gliding is of course from Germany, and the Wasserkuppels. You will recognize.
Yes.
Okay, the next speaker is, now it's about cars. Now so it's not that fun, now it's not boring, but